So today we are having the topic of instruction level pipelining, that is also known as ILP. So we are going to study the ILP. What is ILP? Basically, it is a form of parallelism called as instruction level parallelism is implemented. So what happens in the instruction level pipelining? The multiple instructions execute simultaneously in the instruction level pipelining. The efficiency of pipeline execution is more than that of the non-pipelined execution, which means that instruction level pipelining is more efficient, and it also defines the performance of pipeline execution. So there are some parameters to measure the performance of pipeline execution. The following parameters serve as the criteria to estimate the performance of pipeline execution. The first criteria or the first measurement is speed up, the second one is efficiency, and the third one is known as the throughput to measure the pipeline execution performance. While we talk about the first measure, that is known as speed up. What is speed up? Basically, it gives an idea of how much faster the pipeline execution is as compared to non-pipeline execution. So, what is the formula to calculate the speed up, which is denoted by S? It is as that speed up S is equals to non-pipeline execution time divided by pipeline execution time. So the result which we will get after putting the values in the speed up formula denoted by S, we will have the comparison of non-pipeline execution and pipeline execution. If we talk about the second parameter, that is known as the efficiency, the efficiency of the pipeline execution is calculated as with the help of formula. The efficiency N is denoted by speed up divided by number of stages in the pipeline architecture. Means the value which we got from the first step, speed up, that was non-pipeline execution time divided by pipeline execution time, is again divided by number of stages in the pipeline architecture. Or simply we have the another formula for the calculation of efficiency N is equal to number of boxes utilized in the phase time diagram divided by the total number of boxes in the phase time diagram. So with the help of these two formulas, we can calculate the efficiency of the pipeline execution. And thus we move to the third parameter, that is known as throughput. What is throughput exactly? It is defined as the number of instructions executed per unit time, which means that in a unit time, how many number of instructions are executed. This is known as value of throughput. And how it can be calculated? It is simple as we can see with the help of formula. Throughput is equals to number of instructions executed divided by total time taken. So what is the calculation of important parameters? We can learn that if we consider a pipeline architecture which is consisting of k stages pipeline and the total number of instructions to be executed are equals to n, then how we are going to calculate? If we divide that into the steps or points, the point 1 is calculating the cycle time. In the pipeline architecture, there is a global clock that synchronizes the working of all the stages. Then the frequency of the clock is set such that all the stages are synchronized. At the beginning of each clock cycle, each stage reads the data from its register and processes it. Then the cycle time is the value of one clock cycle. There are two cases possible. In the case first, all the stages offer some delay. What happens in that, if all the stages offer some delay, then the cycle time can be calculated as delay offered by one stage including the delay due to its register. In the case 2, while all the stages do not offer some delay, what happens, if all the stages do not offer some delay, then the cycle time can be calculated as cycle time is equals to maximum delay offered by any stage including the delay due to its register. While we move to the point number 2, that is calculating the frequency of clock, what is it? It is like the frequency of clock, which we know it is denoted by F and equals to 1 upon cycle time. While we come to the third point, it is known as calculating the non-pipeline execution time. What happens in it? In the non-pipeline architecture, the instructions execute one after the other, and the execution of a new instructions begin only after the previous instruction has executed completely. So, the number of clock bytes taken by each instructions is equals to k clock cycles. Thus, the non-pipeline execution time is equals to total number of instructions into the time taken to execute the one instructions. So as we have studied that the number of clock cycles are k and the time is n, so it is n into k clock cycles. While we move to the fourth point, calculating the pipeline execution time. In the pipeline architecture, the multiple instructions executes parallelly and the number of clock cycles taken by the first instruction is equals to k clock cycles. After the first instruction has completely executed, one instruction comes out of the per clock cycle. So the number of clock cycles taken by each remaining instruction is equal to one clock cycle. Thus, the pipeline execution time is equal to time taken to execute the first instruction plus time taken to execute the remaining instructions. So we can calculate 1 into k clock cycles plus n minus 1 into 1 clock cycles. So the value comes as the result k plus n minus 1 clock cycles. While we move to the point 4, that is calculating the speed up, it is simply non-pipeline execution time divided by pipeline execution time equals to n into k clock cycles divided by k plus n minus 1 clock cycles. In the next step, n into k divided by k plus n minus 1, while we simplify it, we get the value as the final result k divided by brackets k plus 1 plus k minus 1 divided by n. So for the very large number of instructions, the n can tends to infinity and the speed up can becomes to k. Practically, total number of instructions never tends to infinity, therefore the speed up is always less than the number of stages in the pipeline. So this was our today's topic, instruction level pipelining. Thank you.